Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today I'll discuss about the chemical characteristics of the solid waste. In a previous lecture, I have discussed about the physical characteristics of the solid waste, in which we have studied all the physical characteristics that will be like this field capacity, that void space, particle size, all those things that is physically related with the solid waste. Because to get a proper method for the disposal and processing of solid waste, their characteristic is very much important. Because of if you know the characteristics of the solid waste, then only you can say that this waste is for which method is better for this type of waste. So today we'll discuss about the chemical characteristics. So, as information on the chemical composition of the component that constitute MSW is important in evaluating alternative processing and recovery option. So, this MSW, see, this MSW is there. Their characteristics we are studying to know which method is important for its processing or recovery, from where it will go, either for processing or recovery. What we should recovery option means which type of method we should adopt for this particular MSW kind of waste. Because in a municipal solid waste, this is a mixed type of waste. So based on its chemical characteristics, we will select its a method of disposal, and the chemical properties of MSW are very important in evaluating the alternative processing and recovery option. So that's why these properties are very important for the evaluation and alternative processing and recovery option. So primarily for combustion, or for the waste to energy, for the conversion of waste to energy calculation, but can be used to estimate biological and chemical behavior. Primarily, we should know this chemical characteristics to burn the waste or to convert waste to energy, to convert it waste from energy, and the calculation. But it is also further used, for the biological and chemical behavior of the particular MSW. So its significance is for waste to energy conservation, energy conversion, waste to energy conversion. And other than this one, it is important to estimate biological and chemical behavior, estimate biological and chemical behavior, biological chemical behavior. So this should be done for this MSW. This will be reflected by the chemical characteristics of the MSW and the information on the chemical composition of the component that constitute whole MSW, and is important in evaluating the alternative processing and recovery option. It is important for the evaluation to understand which method we will do for the processing of this particular type of MSW. And first, after getting all information about its chemical properties, chemical characteristics, we have get idea about which method is important, and this way processing should be done at which place. Next, we'll come to, like this. We'll discuss more on this chemical characteristics, because it is very much important. Like, why we are doing this chemical characteristics of the MSW. So knowledge of the classification of chemical compounds and their characteristics is essential for the proper understanding of the behavior of waste. To know the proper behavior of the waste as it moves through the waste management system, then only this waste management system will be passed. Proper characteristics and proper behavior and chemical compounds is very much important to know. Because of that only we'll get idea about the waste management whole process. The product of decomposition and heating value are two example of chemical characteristics. So to know the decomposition, two main factors here we get. First is decomposition and second is the heating value. To as for decomposition or for heating value are the very important factor, because to know the decomposition means the decomposition process of that waste, or the heating value means by burning the waste, this particular waste, how much amount of energy will get. It will give information by the chemical characteristics. Like that, decomposition process, if it is an organic waste, then by the decomposition of this organic waste, how much amount of biogas we can extract. So this type of information can only get from this chemical characteristic of the waste, because by burning of the waste we'll convert the waste into energy. So, and the wider decomposition process, like decomposition means this composting process, either by aerobic composting or anaerobic composting. So this, as it has been reported in the literatures, like the decomposition of waste process will leads to the getting the of the manure. So it is a, we can say that this is a conversion of waste to resource, and this heating value will get idea about the waste to energy. So two is important aspect of the waste is there. So first is the waste to energy, and second is the resource from waste, resource from waste. So these are now very burning topic. So for these two type of perspective, you have to know its decomposition and heating value of the that particular waste. If solid waste are used as fuel, or are used for any other purpose, we must know its chemical characteristics. So to use it as a fuel or for any purpose, we must know its chemical characteristics. Then only you will do it's a chemical, it's a decomposition process, it's a heating value. Like if this waste consists more heating value, then we can use this waste for the conversion or getting electricity, or getting more burning process. Like this, if this organic waste is organic in nature, then decomposition will be do. So these are the basic meaning, basic requirements, that why significance related with this waste characteristics, this chemical composition of the waste. So in the chemical composition of the waste, what we are studying, first of all, what is the knowledge of classification of chemical compounds and their characteristics is essential for the proper understanding of the behavior of the waste as it moves through the waste management system. So the proper chemical compounds, the classification of chemical compound and their characteristics is essential for the proper understanding of the behavior of the waste. What it is, like the chemical compounds is chemical understanding of the chemical compound and their characteristics and its proper behavior is very much important, because this all leads toward the waste management system. And the product of decomposition and heating value are two example of chemical characteristics. The product of decomposition and heating value will related with this chemical characteristics, and these are some of the example which we are going to study. This will define the characteristics of the waste, like lipid, carbohydrate, proteins, natural fiber, synthetic organic materials, non-combustible way or combustible fusing point of the ash. So the product of decomposition heating value will gives two example of chemical characteristics. Now comes to the next point. This is like what are the chemical characteristics we are studying for this waste management, for this waste. So first of all, it is the pH and N2 nitrogen, NPK, like NPK, nitrogen, phosphorus and potassium, total carbon and CN ratio, total carbon and CN ratio and calorific value. So these 5 points are there, 7 points are there. All these are included in this chemical characteristics of the waste, like pH is there, nitrogen, phosphorus, potassium, total carbon, CN ratio and calorific value. So all these contributes toward the chemical characteristics of the waste. And to understand the proper behavior of the waste, to understand the proper behavior of this proper behavior of the waste, proper behavior and decomposition process, decomposition process, proper behavior and decomposition process, and waste to energy conservation, waste to energy conservation, energy conservation, all should be very important parameters related with the chemical characteristics of the waste. And these are very important parameters that we are going to study. For each things we'll deal in the separate. Now comes to the next point. This is proximate analysis. Proximate analysis is a very important term regarding the characteristics of the waste, like proximate analysis. And proximate analysis, what we are doing this analysis is important in evaluating the combustion properties of waste or waste derived fuel, or the fraction of greatest interest are. And in this proximate analysis will evaluate the properties of waste, like in this waste how much fuel we can derive, waste derived fuel, right? Refuse derived fuel in this waste, This how much this waste is important to refuse to get the heating value. So refuse drive fuel is there, and the fraction and the important points that are considered under the proximate analysis is the moisture content, moisture content, and ash, how much ash it will create, and then volatile matter, and fixed carbon. So, proximate analysis we are studying to get understand to get idea about how much combustion properties of waste are there or waste derived fuels, and for the material recovery facility. As I have discussed, waste ultimate disposal of the waste is the MRF site. MRF site means material recovery facility. So, if this will give idea about how much amount of this material we can recover from that particular waste, how much material we can recover. This is material recovery facility. So for material recovery facility, waste they are separating and sending the waste to MRF site. It is based on its calorific value, like how much amount of heat it will produce, and does it work as a waste derived fuel or refuse derived fuel or not. And for all these to get like information on this, these four parameters are there. First is the moisture content, ash content, volatile matters, and fixed carbon. So these four will all together make proximate analysis of the waste. Next point is the moisture content. So we'll deal all these points on in details. First of all is the moisture content. Loss of moisture occur when it is 104 degrees Celsius, up to 104 degrees Celsius. When you give a temperature of 104 degrees Celsius for approximately 24 hours, like one day, 104 degrees Celsius for one day, then the moisture loss will occur. So, because to get ultimate fuel from the waste, this moisture content should be not present, because moisture adds weight to the waste fuel without increasing its heating value, and the evaporation of water reduces the heat release from the fuel. So, the if more moisture is there in the waste, then the waste the heat release from the fuel is not, is their heating effect is not much. That's why the loss of moisture occur when heated to 104 degrees Celsius for 24 hours. And the moisture, what moisture is doing? Moisture is adding weight and reducing the calorific value of the waste, and it is adding weight to the waste and or the fuel without increasing its heating value. Means this is not increasing its heating value, because already moisture is there. Moisture is some water content is there, so the heating value of the fuel is not increasing, and the evaporation of water will there, and this is going to reduce the heat release from the fuel. So this moisture will obstruct the heat, the fuel, and the heating capacity will be reduced. Like that, ash is there. So in the ash, the weight of the residue after combustion at 55 degrees Celsius, 550 degrees Celsius means for ash it should be 5 degrees Celsius for 2 hours, only 2 hours. In an open crucible, weight of the residue after the combustion at 550 degrees Celsius. This will give you idea about the ash. Ash also add weight without releasing any heat during the combustion process. Ash is going to add weight without releasing any heat during the combustion process. So this is all about the moisture content in ash. They are all a very important factor for the proximate analysis of the waste, and by proximate analysis we will get idea about the waste like this fueled RDF, or it will go to MRF location site, material recovery facility site, how much amount of heating value we can get. For moisture content, moisture will be for to reduce the moisture content, waste should be heated at 104 degrees Celsius for 24 hours. Then this will be without moisture, the waste will be there. Now comes to the next point. This is volatile matter, like additional loss of weight on ignition at that is 700 to 950 degrees Celsius in a covered crucible. This will be the volatile matter in that particular waste, and the volatile matter is that portion of the waste that is covered to gas before and during combustion, and the gases are passed through a combustion chamber where rapid combustion occur. So their temperature is the 700 to 950 degrees Celsius in covered crucible. Covered crucible. Crucible is nothing but a crucible, as you know this word. Crucible is a small this pot is there, which is will put waste inside, and this crucible we are putting inside the muffle furnace. Muffle furnace is there to heat the waste. So muffle furnace, what happens inside the muffle furnace? Anything should be heated on a very high temperature. So additional loss of weight on ignition at 700 to 950 degrees Celsius in a covered crucible. And volatile matter is that portion of the waste that is covered, converted to gas. Means thus volatile matter will be the those things that can be converted into the gas before and during the combustion, and these gases are passed through a combustion chamber where rapid combustion occurs. So volatile matter will get idea about how much this waste can be, what is the capacity of the waste to convert it as a gas, capacity of the waste, capacity of the waste to convert as a gas, convert into gas. So this and volatile matter is that portion, is a little bit portions are there inside the waste, and that volatile matter is going to convert into a gas before and during combustion. With combustion it will convert it into gas only. So they are the volatile matter, and the additional loss of weight on due to during the ignition of 700 to 950 degrees Celsius, during the ignition of 700 to 950 degrees Celsius in a covered crucible. And this will be converted, is that portion of waste that is converted to gas before and during combustion. The gases are passed through a combustion chamber where rapid combustion occurs. Now this let's discuss this physical characteristics of the soil. This is an example of proximate analysis of MSW of Bhopal city of MP. So the source is there, source of for both the data is there. So you can see that in a, if we'll do the proximate analysis of a MSW, that is from the Bhopal proximate analysis. So you can we can see that a general composition of the waste, it is like for the moisture content percentage is like 46%, 28% is the moisture, and 46% is the volatile matters. Means the convert that part, that fraction, that is going to convert into a gaseous compound. And then 9.5 is the fixed carbon that is present in the particular waste. 15% is the ash, and 28% is the moisture. So this is the approximate analysis has been done for the Bhopal city of the MP in Bhopal. This approximate analysis they did for a normal MSW. So you can see that the different groups are there. Means by which unit, by which amount, their proximate analysis is there for the either for commercial site, or for slum, or for group of high income group, middle income group, and LIG, lower income group. And some institute is also there. Average is like 30% is the proximate analysis of the waste that is generated from a Bhopal city of the MP. So you can see that the moisture content is around 30 in a commercial. In the slum it is more, 34% up to. High income group, it is moisture content is less, because in high income group most of the waste are paper waste, cardboard waste, and middle income is also approx 28. Lower income group is having more moisture content. Then the institute is also less, and average is 30%. 30% is there. Like that, volatile matter is way more in high income group people, and less in you can see that in either in a commercial or in a slum area. And the ash content in the waste is everywhere, it is same, only the middle income group is more, like 45, and 42 is average. Like that, fixed carbon, how much amount of carbon is there. So it is all again, it is like 6 to 7 to 8 range is there for all the waste, and that's why on the basis of it calorific value has been calculated. And calorific value is the kilojoule per gram. Means per gram of the waste, how much kilojoule of energy is it is coming, how much energy we are extracting. So for commercial area it is nearby the 4,000, like slum 30,000, 3,900, 4,000, 4,500 for the high income group. And a middle income group is like MIG people is like 4,200, and LIG group people is 4,000 approx, and institute is also 4,500, and average is 4,000, 4,200. So this is the source of this is like characterization of municipal solid waste in a Jalandhar city of Punjab. This has been published in a Journal of Hazardous Waste of Toxic and Radioactive Substances. And this study has been done by the Katiyar RB and Sundar Murthy Suresh, and that has been from the characteristics of the municipal solid waste generated by the city of Bhopal, India, International Journal of Chemical Tech Research. From this, we'll get this data. Like you can see that for the average proximate analysis of MSW in Bhopal, and this is the proximate analysis in the city of Jalandhar in Punjab, that is in Jalandhar city. So these are two other example that is reflecting the physical characteristics of the waste in our locality, or which type of waste we are producing. And that has been divided into different categories like commercial, slum, high income group, LIG, MIG, LIG, HIG, or like institute. And on an average, what is the percentage of moisture content, or what is volatile matter, fixed ash content, fixed carbon content, and calorific value of that particular waste. Now comes to the next point. This is about the fixed carbon. We are calculating fixed carbon of a waste. Like, what is fixed carbon? So the combustible residue left after volatile matter is removed. Combustible residue that is left after the volatile matter is removed. So fixed carbon represents the carbon remaining on the surface of the grades as char or waste or fuel. With a high proportion of fixed carbon requires a long retention time on the furnace grades to achieve complete combustion that does waste or fuel with a low proportion of fixed carbon. That's why moisture percentage plus ash percentage plus volatile amount in the percentage, and then fixed carbon all in the percentage is equal to 100%. So this is like a fixed carbon is like the combustible residue that left after volatile matter has been removed, and this fixed carbon represents the carbon remaining on the surface of the grates as char and the waste or fuel. With a very high proportion of fixed carbon requires a longer retention time on the furnace grates to achieve complete combustion than does waste or fuel with a low proportion of fixed carbon. So this is all about the carbon. And next is the ultimate analysis. Ultimate analysis is the another part. So ultimate analysis of the waste is carried out by to determine the proportion of carbon, hydrogen, CHNOS, like carbon, hydrogen, oxygen, nitrogen, and sulfur. So CHONS. So this will give, like, the ultimate analysis is useful during mass balance calculation for chemical and thermal processes. This ultimate analysis is useful during the mass balance calculation. During mass balance calculation for chemical and thermal process, the results are used to characterize the chemical composition of organic matter of MSW. This result is used, means this ultimate analysis will give you information about the organic matter that is present in the MSW. So before I have discussed like proximate analysis. Proximate analysis will give you idea about the how much fuel it can be converted. Like that, this ultimate analysis will give you information about the composition of organic matter of the MSW. Also, it will be a next point is that it is used to define proper mix to achieve suitable CN ratio for biological conversion process. It will define proper mixing to achieve suitable CN ratio. Suitable CN ratio means how much it is used to proper mix to achieve CN ratio for biological conversion process, and it can be analyzed in the CHNOS analyzer. CHNOS analyzer has been used to determine this CHNOS. This will give idea about the decomposition of the waste. Like this. Now comes to the next point. This is like energy content, like calorific value. How much calorific value is there in that particular waste? How much amount of energy content is there? So energy content of the component of the MSW can be determined by these three type of method. First is using a full scale boiler or a calorimeter, or using a laboratory bomb calorimeter. Here you can see that this picture of this, and calculation. If we know the elemental composition is known, like CHNOS ratio we know, then we can calculate it by manually. But to know the organic component of the MSW, we will use this thing, that is calorimeter. Picture of a bomb calorimeter, where thermometer is there, a stirrer is there, water in the stirrer will put waste, and oxygen and vessels are there. So in this with this bomb calorimeter, we'll get idea about the full scale boiler or a laboratory bomb calorimeter. This will get idea about the elemental composition of the waste or the energy content, like the total calorific value of the waste, total calorific value. Total calorific value of waste. Now comes to the next point. This is like the because of the difficulty in instrumenting a full scale boiler, most of the data on the energy content of the organic component of the MSW are based on the results of bomb calorimeter test. Mostly bomb calorimeter has been used. So in India, energy content measured in kilocalorie per kg. Kilocalorie per kg. The unit to measure energy is the kilocalorie per kg, and 1 joule is equal to 0.24 gram per calorie. And the energy content can be calculated by this formula: 145 carbon, 600 hydrogen, oxygen, S and S. This is the formula. Like I told you, like CHNOS can be used to calculate the energy content of the particular waste. So CHNOS, if we know its elemental composition, or if we know its total amount, then we can calculate it by this method. CHO2, these are the percentages by weight. By weight we are using, and 1 BTU is 1055.6 joule, and 2.326 BTU per LV is equal to 1 kilojoule per kg. And energy can be calculated by in the kilojoule. So this is all about the energy content of the waste. And now we can see that the calorific value and moisture content of the MSW in a general Indian city is, its a source is CPCB NEERI. NEERI, that is National Environmental Engineering Research Institute, 2016. So if a city with a population that is less than 1 lakh, the minimum calorific value 1234 kilocalorie per kg. Like this city with a population of 1 to 5 lakhs, you can see the moisture content and net calorific value, because moisture content is also important to know the calorific value, because moisture will hamper the will reduce the heating capacity of the waste. Cities with population of 5 to 10 lakhs, you can see this is the average data of the cities with population of 5 to 10 lakh, and like city with a population of 10 to 20 lakhs, and city with population above 20 lakhs. So these are the moisture composition: minimum, maximum, and mean. Like this, though mean and average is the 47% of moisture in the 1772 kilocalorie per kg of the waste. So this is the normal calorific value and moisture content comparison in a normal MSW in an Indian city. Next, we'll give information on the calorific value of the different fraction of the waste. Means which type of waste. As we know, MSW is the mixed waste. So we are dealing with the general MSW. So in the general MSW, which type of waste are present? Like it is a paper and cardboard, organic material, plastic, glass, metal, textile, or some inert material. So paper and cardboard percentage is 3,821. Obviously, paper will burn very fast. So the amount of heat or net calorific value we can get from the paper and cardboard. Like this organic material, plastics are there, glass cannot be heated, metal cannot be heated, textile is there, like, and some other materials is also there. So this is the net calorific value in kilocalorie per kg. Next is the metal content. Total metal content in the waste is also comes under the chemical characteristics. The metal content, like metal, these metals are the heavy metals, like toxic heavy metals, or we can say the toxic metals. So the example of metal content is cadmium, chromium, mercury, nickel, zinc, manganese, lead, arsenic, etc. So it also be determined because of its potential harmful environmental effects, because these heavy metals are a very toxic metal and that is very much dangerous. So if it will be released into the food chain, so that this metal content should be also be determined before before making it for the processing unit, before sending it to the disposal site. So this metal content can be measured by this method: atomic absorption spectrophotometry, and other method is also that is ICP-OES. but this is a quite expensive method that is not available everywhere. But in generally in CPCB and general in the municipality, this AAS is there. So mostly this AAS has been used to detect the metal content in the waste, and to understand its harmful effect and the toxic effect related with this particular waste. So as I have discussed about the chemical characteristics of the waste, that has been very important aspect. Like to we have to know the ultimate decomposition and the proximate analysis of the waste to know it's either it's a decomposition rate or it's a material recovery rate. Either we'll get fuel from the particular waste, or we can send that waste for the decomposition process, or by the decomposition process we'll get a biogas or anything. So these are the some of the references that is in some textbook that you should follow for to know all these processes, to know all these things. Now I'm concluding my lecture with this point, like that I have discussed about the chemical characteristics of the waste. In the next class I will discuss about the biological characteristics of the waste, because the biological characteristics is also an important aspect that is related with the waste management. To know the biological characteristics is also very important. All three characteristics, like physical, chemical and biological characteristics. So before sending any waste for material recovery facility or for recovery site, these three characteristics should be known. So that I this is the biological characteristics. And next I'll discuss about some next in the next class I'll discuss about biological characteristics. So if you have any queries or any doubts regarding this lecture, you can write in the comment box, or you can send me directly mail onto my given mail id, shikha.pandey@gmail.com. And that's all for today's lecture. Thank you. We'll meet in the next class, and I'll discuss about the biological characteristic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.